Hello everyone, today in this video we are going to talk about the application of triangle law of vector addition. So after this video you should be able to apply the triangle law to solve real life problems. So this is the triangle law. It says that if two vectors represent the two sides of the triangle, then the third side of the triangle will give the resultant of two vectors. So the magnitude of the resultant vector will be given by this expression, and the direction of the resultant is given by this expression. So there is a way to remember this formula for the angle meter, and out here in the denominator we'll write the vector which is opposite to the angle. So out here you can see B is opposite to this angle, so we'll write B. If A is there, then we'll write A. So at this point we'll write the vector which is opposite to the resultant. So you can see at the opposite of resultant we have vector A, so I'm writing A out here. So this is how we remember the formula for angle. So this is the first question. Two forces whose magnitude are in the ratio of 3:5 give the resultant of 28 Newton. Find the magnitude of each force if the angle between them is 60 degree. So out here the two forces are in the ratio, so 3:5. So we'll write A is equal to 3x and B is equal to 5x, and resultant is given 28 Newton and angle is given. So we know to find the resultant we can use this formula. So out here we can put the values. So resultant is 28, A is 3x, B is 5x, and theta is 60 degree. So if you solve this, you will get x is equal to 20 Newton. After solving this, you can find A is equal to 3 into 20. So you will get 60 Newton and B to be 100 Newton. So try this question by yourself. So this is the next question. Two forces have their resultant equal to either. Find the angle between them. So in this question, it is saying that the two vectors and resultant have same magnitudes. They are equal. That means A is equal to B is equal to R. So we have to find theta. So this is the formula to find the resultant. So instead of A, instead of B, and instead of R, we'll put R. So now if you solve this, so I'm taking this root over and giving square to this R, and I can cancel this R square and R square. You'll get 0. Then again you're left with this. So again this R square get cancelled. So cos theta will be minus half, and cos 120 degree is minus half. So theta is 120 degree. Angle between two vector is 120 degree. Now this is the third question. Our motorboat is racing towards the north at 25 km per hour, and water current in that region is 10 km per hour in the direction 60 degree east of south. Find the resultant velocity of the boat. So in order to solve this question, we have to make use of diagram. So this is north, south, east, west, and boat is going towards the north. So velocity of boat is towards the north, and velocity of current is 60 degree east of south. So from south it is going towards the east with angle 60 degrees. So this is the velocity of water current. So now you can see this angle is 90, so the leftover angle is 30 degree, and out here is 90 degree. So angle between two vector is 90 plus 30, that is 120. Now I have to find the resultant velocity of the boat. So boat will try to go this side and water will try to bring the boat downward. So there will be another velocity, that is resultant velocity, which I have to find. To find the resultant velocity I have to make use of triangle law. So right now I cannot use triangle law because I am getting tip and tip. So in order to use the triangle law I have to get tip and toe. So in order to do this I can shift this vector out here. So tip of this vector and toe of this vector come together. So now you can see tip and toe together. So I can use the triangle law. So third side will give the resultant. So I have to find this resultant, and this is the angle made by the resultant with VW. So we have to find this resultant and beta. So these are the things which are given. So I have to find resultant, theta and beta. So theta is already 120 degree, so I have to find the resultant. So to find the resultant, I'll make use of this expression. So out here A can be written as VB and B is VW. So I'll put the values, and cos 120 degrees minus half. If you put cos 120 is equal to minus half, and if you solve this, you will get R is equal to root over 475 kilometer per hour. So that is the resultant velocity. Now I have to find the angle. So beta is the angle made by the resultant with VW. So this is the formula to find the angle. Beta is equal to tan inverse, and out here I'll write the vector which is opposite to the beta. So out here opposite to beta is V boat, so I have to write V boat out here and V water out here. So if you solve this, and sine 120 is root 3 by 2 and cos 120 is minus half, if you put the value, you'll get beta is equal to tan inverse of minus 5 root 3 degree towards the north from the direction of VW. So from VW, this much angle towards the north. There is another way to find the direction of the resultant. Instead of finding this angle, you can find this angle like this. So out here you can see, instead of this angle, I have considered this angle to be beta. So now the vector which is opposite to the beta will be VW. Now this time formula will be just opposite. So out here will be VW, because here and here I have to write the vector which is opposite to beta. So out here opposite to beta is VW. I have shifted this out here. So if you solve this, you will get beta is equal to tan inverse root 3 by 4, and this angle is towards the east from the north. So I have to write degree towards the east from the north. So you can take whichever angle you like, either this or this. So next question, on a certain day, rain was falling with the velocity of 35 meter per second. A wind started blowing after some time with a speed of 12 meter per second in east to west direction. What is the final velocity of the wind? In which direction should a boy waiting at a bus stop hold his umbrella? So the rain is falling down with the velocity 35 meter per second, and wind is blowing from east to west. So I have to find the final velocity of the rain. So angle between two vectors is 90 degree. Now I have to find the resultant velocity of the rain. So to find the resultant velocity, I have to make use of triangle law. Right now I cannot make use of triangle law because tip and toe of two vectors are not coming together. So I have to shift one of the vector. So I'll shift this down. You can shift this side also, but for now I'm shifting this. You can shift this also. So now tip and toe are coming together, so I can use triangle law. So these two vectors are the two sides of the triangle, and the third side will give the resultant. If the rain is falling in this direction, we should hold the umbrella in the same direction. So we should hold the umbrella like this, so that the umbrella face towards the direction of velocity of the rain. So I have to find this angle. So this angle is the angle along which the boy should hold his umbrella. So these are the things which are given. Velocity of rain is given and velocity of wind is given. Angle between two vectors are 90 degrees, so I have to find R and B. So please do not write R cap out here because we are finding the magnitude. So this is the formula to find the magnitude. So if you put the values, you will get R to be 37 meter per second. So the final velocity of the rain is 37 meter per second. And now the direction, so we have to find the beta. So this is the formula for beta. Beta is equal to tan inverse. So out here I have to write the vector which is opposite to the angle. So out here you can see velocity of wind is the opposite to the angle. So velocity of wind sine 90 and divided by velocity of rain plus velocity of wind cos 90 degrees. Out here theta is 90 degree. So if you put the value, you will get beta is equal to 10 inverse 12 by 35, because sine 90 is 1 and cos 90 is 0, so you don't need to put anything out here. So it will be 12 by 35. So the boy should hold the umbrella at an angle 10 inverse 12 by 35 towards the east. So this is another question. A river 800 meter wide flows at the rate of 5 km per hour. A swimmer who can swim at 10 km per hour in still water wishes to cross the river straight. Along what direction must he strike? What should be his resultant velocity? How much time he would take to cross the river? So let's draw the diagram. So this is the river 800 meter wide, and suppose this is the velocity of water. So water is going from left to right, and swimmer want to cross the river straight. The swimmer wants to reach at this point. So in order to reach at this point, he must dive in this direction, so that the combined velocity of swimmer and water bring him to this point. So if he dives in this direction, he will come to this position afterwards. So this will be our resultant velocity, which is straight line. So resultant velocity is the combination of these two velocity of swimmer and velocity of water. So I have to make use of triangle law. So I should shift this vector out here, so that tip and toe of these two vectors come together, and this will be our resultant. So these two vectors are the two sides of the triangle, and third side is representing the final velocity of the swimmer. So now this angle is beta and this angle is theta. So out here angle theta is not given, so I cannot use the formula for the resultant. So these are the things which are given. So now this is the formula to find beta. So but we are not using this, because out here we can see our triangle is right angle triangle. So for right angle triangle we don't use this formula, so we can directly find beta is. So in this triangle, sine beta is velocity of water by velocity of swimmer. So if you put the value 5 by 10, you will get half. So sine 30 degree is half, so beta is 30 degree. So now let's find theta. So theta is this 30 degree plus this 90 degree, so total is 120 degree. So now I got theta. Now I can find the value of resultant. So this is the formula for resultant. So if you put the value, and cos 120 degrees minus half, so let's put the value. So after putting the value, you will get r is equal to root over 75, that is equal to 8.66 kilometer per hour. Now we'll convert this kilometer per hour into meter per second. So we'll multiply by 5 by 18, so you will get 2.4 meter per second. Now we have to find the time. So we know speed is equal to distance upon time. So time is distance by velocity. So distance is 800 meter and speed is 2.4, so you will get 333.3 seconds. So swimmer will take 333.3 seconds. So there is an alternative way to find the resultant. So instead of doing this formula, you can directly use Pythagoras theorem, because out here you can see this triangle is right angle triangle. So for right angle triangle, we don't need to make use of this formula for resultant or another formula for beta. So we can directly use sine beta and we can use Pythagoras. So you can try this question by using Pythagoras also. So now you can try these questions. Out here you can see answer is given in 53 degree. So out here you don't need to find this 53, you can leave the answer in 10 inverse of some value. And in this question the angle is given, that is 2 pi by 3. 2 pi by 3 means 2 into pi is 180 divided by 3, that is 120. So this angle is 120 degree. So other question you can try. So this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.